Good afternoon to all. My name is Abhishek Kumar. I'm working as assistant professor in Department of Computer Science and Engineering, Artificial Intelligence in IIMT College of Engineering, Greater Noida. Today I am discussing one very important topic regarding to the data structure, algorithms, as well as PPS from the today from the AK2 syllabus. The topic name is algorithm and asymptotic analysis. If any students who are studying the B.Tech course from the AK2 syllabus, and if you go through the syllabus, then this topic you have to study in first semester in the PPS subject. Again, when you will move to the third semester, then also you have to study the same topic in the data structure. And when you will move to the fifth semester, then again the DA also we have to study this subject, this topic. So this is the very important topic, and this will be give you clear idea about that what is the meaning of algorithms and what are the different type of algorithmic analysis concepts are there. So in this lecture schedule, I am discussing about the basic idea of algorithms. What do you mean by algorithms? And what are different analysis techniques? Basically, there are two different analysis techniques that we are following in the algorithms. One is called experimental analysis, as well as it is called absolute analysis also, and one is approximate analysis, or it is called asymptotic analysis. Then also we will discuss about what are the different fundamental functions that we are using in the algorithms. Then that if you have defining the time complexity, so what are the different functions that we are using. Then based on that, we will come across one graph, and that graph will give you the clear idea that what is the meaning of different types of fundamental functions, and if the input size will increase, then what will be the impact on the total time complexity. And the last topic that we will discuss today is the asymptotic analysis. I think the students who are familiar with this topic, they know about that. Basically there are three different notations that we are using in the asymptotic using the asymptotic analysis. One is we are talking about big O notation, then we are talking about big theta, and then we are talking about big omega. Two more smaller notations also we are using. One is called a small o and one is called a small omega. So these are the brief overview of the topic that I am discussing. So first of all, let's come to the basic idea of what do you mean by algorithm. So as all of you know, what is the basic idea about the data structure? That data structure is a way through which what we are doing, we are organizing and accessing the data. So if you all of you know that if there is one problem, and if you want to solve that problem with the different data structure, then our complexity will be reduced. Based on the different data structure that we are taking, based on that, what will happen, the complexity will reduce. So basically the data structure is that we have to organize the data in a systematic way so that we can access the data very efficiently, and the time that is required will be also less. And the basic definition of the algorithm is that it is a step-by-step procedure to performing some task in the finite amount of time. So basically, if we are going to the different type of characteristics of algorithm, so there are five basic characteristics of any algorithm. That will be that any algorithm should have set of inputs. Also, it must have produced a set of outputs. Then second will be that it must be complete. Fourth will be that it must be finite. And fifth basic characteristic is that it must give the optimal solution. So based on these five, there are five different characteristics of any algorithm. So if we are writing any algorithm and if it is obeying these five characteristics, then we can say that this is an efficient algorithm. And one important thing is that when we are writing, what is the basic difference between algorithm and the program? So algorithm is a set of instructions. So if any students who are listening to the class who are in the third semester or the fifth semester, then they must come across one term that is called pseudocode. Pseudocode will be just similar to our English languages, and it will be the pseudocode will be called algorithm. So we can say that algorithm will be a abstraction, and program will be one implementation part. So In the case of algorithm, when we have to analyze the algorithm, because for a particular problem, there may be number of algorithms we can design. So how we can measure that this algorithm, let's assume there are a number of algorithms A1, A2 up to AN. So which algorithm will be better? How we can able to decide? To decide that, there are basically two basic parameters that we are using, or two basic constraints that will be the parameters that we are using to analyze an algorithm. That will be, one will be called time complexity and one will be called space complexity. So what is the basic idea about the time complexity? That if we are writing any algorithm, so if that algorithm will be executed, so how much time it will take, that will be called time complexity. And what is the basic idea behind the space complexity? That if we are writing any algorithm, so first of all, that algorithm will be, if we are writing the code, so that will be stored in memory. So when it will be come into the main memory for execution, then how much memory space it will take, it will call a space complexity. But nowadays, when we are considering, or when we are analyzing the algorithms, so our main focus is on the time complexity. What is the reason for that? When we come across to the different sites, then we can able to understand that why we are more focusing on the case of space, time complexity. So so the thing that I was talking about, the time complexity of the algorithm is defined as the time required to execute that program. And when the input size will increase, that means when the number of input for any problem will be increased, then time complexity also increase. And maybe chances that if there are same number of inputs, but the input order, if we are changing the input order, then also our time can be changed, as well as what will be the our system configuration. That means what is our hardware configuration. That means which processor we are using, what is the clock rate, how much RAM we are using, what is the disk space. This also affect our time complexity, as well as which type of operating systems we are using, which type of programming language we are using. That means let's assume if we are writing one program that we're executing in the Windows, and in the same program we are executing on the Ubuntu, it may be chances that some operating systems will take extra time, some will take less time. So these are the four factors that will affect our time complexity. So based on this, there are basically two types of analysis that we are doing in the case of algorithms. One will be called experimental studies, or it will be also called absolute analysis, and one is called approximately analysis, or it will be called relative analysis, or it will also call asymptotic analysis. So what is the basic idea in the case of experimental analysis? As all of you come across these ideas, that if we are writing one program and if you want to compute that how much time that program will take, so in any language, if we are familiar with the C, then the C also we are using one when we are using one studio file, that means as input time.h. And what we are doing that when we after main, what we are doing that first of all we are writing t.start, and we are storing that value in one variable. Then after the execution of the last line of the code, again we are writing t.end, and again we are writing one variable. Then based on that, what we can take, we can compute the elapsed time. So that will be called experimental analysis. That means what the in experimental analysis to do, it will give the time to correct time to solve a particular problem. So here you can see here that in the case of the experimental analysis, what are the things that I am writing in this slide? That the running time of an algorithm can be computed by executing it on the various test inputs and recording the time spent during each execution. So there are, if you see, if you can see the last line of this slide. So I am taking a snapshot from the Python programming language. So what here I am writing, that I am writing one import time function from time modules. Then what we are doing, that first of all I am computing the start time. Then I am running the algorithms. Then again what I am computing the end time, and then how we can able to measure that how much time my algorithm will take. That means we are taking the elapsed time, that means end time minus start time. So this is the basic idea about the experimental studies. But what are the disadvantages, or what are the limitations, or what are the different type of challenges we can face in the case of experimental analysis? So the basic one is that if if there will be different type of hardware configurations are there, that means if we have to measure the experimental analysis and we have to generalize, then what is the basic thing that we have to do? That all the systems must have the uniform or the same hardware and software configuration. If the system configuration will change, by default, our running time or our experimental time will also change. So that is the first case, as well as for the any input, we have to design the test cases, and that there may be only a finite amount of test cases we can able to design. So that will be that if we cannot able to write the experimental, we cannot able to write the correct uh, time for all types of inputs. And third will be that if we have to study that how much time my algorithm will take. So first of all, what I have to do, I have to write the code, then I have to execute on any particular system. Then only we can able to measure that my algorithm will take this much amount of time. So these are the basic three challenges that we are facing in the case of experimental studies. So when in the next slide, coming slide, I will discuss about the asymptotic analysis. So what the basic difference between experimental and the asymptotic analysis? Then in the experimental analysis, we are measuring the exact time. But in the case of asymptotic analysis, when we are measuring the asymptotic behavior of any function or any algorithms, so what we are taking that how much the different in our program or in our algorithm, what are the different primitive operations that we are doing, and all the primitive operations we are computing, then we can able to measure the asymptotic behavior. So we can come across this. So what are our goals here? That we can able to uh, generalize our approach in such a way that that means if we are writing an algorithm if we are writing on same algorithm and if we are executing our algorithm in two different environments, either that system will have the same configuration of the hardware or the software, or it have the different configurations, but it should give one exact solutions, that our efficiency or our algorithmic time should not vary. So this is our first goal. As well as second, our goal is that we want to, without implementing our ideas in the true sense, that means without writing the code, what we are doing, just we want to, when we are writing any pseudocode, at that time we want to measure that my pseudocode or my algorithm, how much time it will take. That means we want to study the high level description of the algorithm. That means we do not want to implement first, then we can able to measure. So that is the thing. And the third will be, because in the case of experimental studies, there will be only a fixed amount of test cases. So for all set of inputs, we cannot able to measure our time complexity. But in the case of asymptotic behavior, we can able to measure all type of, we can give the different type of input cases, input set of inputs, and we can measure the time complexity. So these are our goals. So first of all, you can see this graph. This is a very important graph. From this we can able to understand that what is the meaning of best case, what is the meaning of worst case, what is the meaning of average case. And when we are going to the asymptotic analysis also, then we will discuss about three different notations. One will be called big O notation, one will be called theta notation, and one will be called big omega notation. So in the big O notation will be called as worst case time, or it will be called upper bound. Our best case time will be called as big omega notations, or it will be called lower bound. And the theta notation will be called average case. So what is the basic idea of this? That what is the meaning of, what is the basic significance of these notations? That worst case time means, that means if we are writing any algorithm and if we are giving different set of inputs, so my algorithm will take maximum that amount of time, that will be called our worst case, or it will be called upper bound. So if for the, here you can see in this graph that let's assume that there are different type of input instances. Instances we are giving the different set of inputs. Let's assume A, B, C, D, E, F, G, H. For the same number, same algorithm. For one particular algorithm, let's assume we are giving different set of inputs. So here in this graph, we are denoting in the form of A, B, C, D, E, F, G. So you can see for some inputs, our running time is highest. For the some inputs, our running time is smaller. For the some cases, it lies between the best and the worst. So what is the basic idea here that if you see this graph, so in the case of uh, input set A and the input set D, it is taking the maximum amount of time. That means it is called our worst case. And when we are going in the asymptotic analysis, so it will be denoted by BIGO notation. But in the case of if we will see this graph, then in the case of uh, test input E, it is taking the smallest time. That means it is taking the best case. So it will be called lower bound, and it will be denoted by big omega notation. And you can see for all other input, either for the B or the C, or in the case of F or G, the time is lying between best on the worst. That means either it will be lying between minimum and the maximum. So this will be called average case time, and it will be denoted by in the case of asymptotic analysis, it will be denoted by big theta notation. So first of all, before going to the asymptotic analysis, just I want to come across one more important topic, that these are the different type of functions or fundamental functions that always we will come across when we are analyzing the algorithms. So basically, there are 7 different functions that we are generally using in the case of asymptotic analysis. One is called constant function, one is called logarithmic function, third will be our linear function, then our n log n function, then quadratic, then cubic and polynomial, and finally will be exponential function. So first of all, I am going about this one by one. I will discuss some important properties of this constant functions. So constant function means that it is a very simple functions. If you are seeing that if fn is 10, fn is 1, fn is 100, fn is any value, that is constant. That means either the value can be 5, value can be 27, value can be 2 to the power 10. These all value will be called constant functions. And if we are talking about which are the operations that will take the constant functions, so if we are familiar with any programming language, then the statement that we are writing in the printf, scanf, or if we are doing any algebraic computation, that means either we are adding two values and storing in one variable, which all different operations will take constant amount of time. So this is the very fundamental functions. And what is the basic, how we can able to define that fn will be called c, fn is equal to c for some fixed constant c, where the c value can be any value, either it can be a positive value or it can be a negative value. So here you can see, if you come to the last line of the slide, so what are the where it will be take constant time, that means characterizing the number of steps needed to do basic operations on computer, like if we are adding two numbers, assigning a value to some variables, or comparing two numbers. So this all primitive operations will take the constant functions. So next comes to the logarithmic function, very important function. And if you see this algorithm, all of you come across one searching techniques, it will call binary search. So if we are finding the binary search time complexity, it will come in the form of log n. And because here in the computer science we are dealing about the binary numbers, so always when we are talking about log n, that means log n base 2. Because as all of you know that if in the case of decimal number system, when we are talking about log n, means by default log n base 10. Because in the case of computer science, we are only talking about either 0 or the 1. So here always the log n means, that means log n base 2. It is the inherent meaning that when we are writing log n, means it will log n base 2. So the basic idea will be that it will be f of n equal to log n base b, where the base b will be always greater than 1, but by default our b will be 1. So if you remember that in the case of binary search, what we are doing, that when first of all we are computing the mid value, then based on that bit, if our key value is the mid, that will be our best case. Otherwise, we are searching in the left half or right half. So what we are doing, if you go to the recurrence solution of binary search, it will be called T of n equal to Tn by 2 plus C. And if we are solving by any method, either you are going for a substitution method, or we are going for recursive tree approach or the master theorem, any approach if we are using. So in that case, it will come to the log n. So that is the logarithmic function. Okay, there are some basic rules. I think all of you must know about that because this is a high school mathematics. That if there are three real numbers, a value is greater than 0, b is greater than 1, c is also greater than 1, and d is also greater than 1. Then if we are writing log AC base b, so we can write that multiplication can be converted to addition. That means log a base b, log c base b. Like that, log b a by c, it will be log a base b, log c b. All of you, I think, come across this term because this is a high school mathematics. And when we are solving different algorithms, in the case for the logarithmic functions, so this property will be very useful. Now comes to the third function, that will be our linear function. So in the linear function, very simple example will be that if in any program, if you are writing any for loop or while loop or do while loop, by default, it will take linear time. Because in the case of, let's assume, or if you come across the linear search will show what we are doing, that there are n number of inputs in an array, and we are assigning one key value, and from the first value to the last value, we are going by one in the sequential order. So that means we have to write at least, we have to come across, we have to scan all the input at least once to find one value. So it will be our linear functions. So very simple functions also is that f of n equal to n. That means given an input value, the linear function f assign the value n itself. So here, the example, that is same example that I am writing in this slide, that if there is a n number of input, and if you want to search a particular element, then it will require n number of comparison. And in the previous slide also, when we are talking about the constant functions, if we are comparing one value to another, it will take constant amount of time. So for that case, it will take the constant amount of time. Now comes to the next function, very popular function. It will lie between n log n. It will lie between our linear and the quadratic functions. And if this is a function, if we are going for any sorting techniques, that is the most popular functions, and the time complexity will be generally lie between n log n. For the merge sort, for the quick sort, heap sort, number of sorting techniques are there. For them, the functions and the complexity will be lie between n and linear and the quadratic. That means it will be n log n. So what we are doing in the case of this, that means it will be f of n equal to n log n. That means function that will assign an input n, and what we are doing, we are multiplying with log n. So this will be this function will grow more rapidly than the linear function, but it will be less than the quadratic functions. So if you will go in if you go in fifth semester, then we have to study different type of sorting techniques. So basically, all the sorting techniques are divided in two categories. One will be compared based sorting, compare best sorting, and one is non-comparable sorting. So in the comparable based sorting, either we are going for quick sort or merge sort or selection sort or bubble sort or insertion sort. There are different type of comparison based sorting. So this is one theorem that if any algorithm, if any sorting techniques that is based on the comparison means that either we have to arrange in the increasing or the decreasing order, always we are comparing the adjacent values. So in that case, the minimum time required to sort any particular set of inputs will be n log n. That is one theorem, and that is proved in when you go in fifth semester when you study the DA. So you can come across this. Then there is one more category of algorithm that will look at non-comparable sorting. In that we have to study about the counting sort, radix sort, and bucket sort. So here what will happen when we have to arrange the element, we will not arranging the elements based on the comparison. We have using the different techniques. So for that it will take the linear time. So this is very important functions, and when we'll come across the different sorting techniques in your higher study, if any students who are in the fifth semester, then they may have come across these functions very frequently. Now comes to the next function, that is quadratic function. Very simple idea. If in any program, if we are using nested for loop or nested, that means if you are writing one for loop inside one for loop, again we are writing. So by default, it will take n square time. So this is a very popular functions also. So f of n equal to n square. That means given an input instance n, that it will assign the product of n with itself. So now comes to the one more function, that is cubic functions. So if all of you surely come across, they're very popular program. That means if you want to multiply the two matrices. So in that case, what we are doing, we are writing three for loops. Two for loops for the one for loop to access the rows, second for loop to access the columns, and one more for loop we are writing for the third array. So in that case, what we are writing three for loops in consecutive orders. So it will take order of n cube. So for matrix multiplication, the time complexity will come to the order of n cube. And for all these, either that function will be our linear or quadratic or cubic, all will becomes in the form of one generalized form that will be called polynomials. So if all of you must have studied the polynomials in high school mathematics, so the general forms of the polynomial will be f of n equal to a0 plus a1n plus a2n square, a3n cube up to an adn to the power d. So here you all of you know this a0, a1 up to ad will be called constants, and n to the power 0, n to the power 1, n to the power 2, n to the power 3 up to n to the power d, it will be called coefficients. And one more important point is that in the case of polynomial, what will be our degree? That will be it will be that what will be the highest power of any coefficient, that will be called degree of the polynomials. So here you can see that these are some examples of polynomial. That means f of n equal to 2 plus 5n plus n square, or f of n equal to, that will be our the first example is our quadratic. Second one is f of n equal to 1 plus n cube, that means cubic polynomial. F of n equal to 1, it will be our constant. F of n equal to n, it is our linear function, linear. And f of n equal to n square, it is our quadratic. Okay, so you can see this, that these are the some examples that will be called polynomials. And the last class of the function is our exponential function. Exponential function will be how we can able to define that f of n equal to b to the power n, where b is a positive constant and call the base. So if you come across, I think all of you, the students who are in their higher semester, in the third semester or the fifth semester, so you come across one problem that will be called sum of subsets. In the sum of subsets, what is the basic idea? That in the set, let's assume there are 5 number of elements. So if there are 5 number of elements, so how much number of subsets we can able to construct? It will be 2 to the power 5. Because all of you know there is one formula that if there are n number of elements, then the total number of subsets will be 2 to the power n. So what we are doing in the case of sum of subsets problem, that will be solved with the help of either dynamic programming or the backtracking or the branch bound. So what the basic things that we are doing in the case of sum of subsets problem, that we have to take different subsets of a particular set, and we have to see that which are the subsets that is satisfying our criteria or our constraint. So in that case, if we are taking, if we are measuring the complexity of this will becomes to order of 2 to the power n. Because for n number of input, there will be not maybe, there will be 2 to the power n number of subsets. So this is the basic, or you can see that if there are n bits of number, and if you have to count that how much number of how much, if there is one n bit of word, and if you have to find that how much if there are n bits, and if you have to find that how much word we can able to create, so it will be 2 to the power n, because for n bits either that bit can be either 0 or 1. That means for each bit there we have two possibilities. That means for each bit, if there will be n bits, so for each bit we have two possibilities. That bit can be either 0 or it can be 1. So there will be that the total size of the word can be 2 to the power n. And the last, if you come across the last lines of this slide, so here also there are some properties of exponential rules. All of you must have studied this in your high school mathematics. That if there is one polynomial of b to the power a, and if we are taking the b to the power a to the power c, so what will happen? Both the degree will be multiplied. That means it will be b to the power ac. And if there are two different polynomials that is having the same base, that means b to the power a, b to the power c, so we can write as b to the power a plus c. As well as the third rule, that b to the power a divided by b to the power c, so this will be called as b to the power a minus c. Now coming to one very important that's this slide will give you the idea that what are the different functions that I was discussing about and what is the basic significance and why we have to always write an algorithm that will take either complexity in the form of n square or n cube. Because if we are writing any algorithm and that is taking the time that will be more than n cube, so in that case it will face some difficulty because we cannot able to solve that problem in the finite amount of time. So now we can see here that this is one graph and that will give you the basic idea that will give the basic idea about that what is the what are the different seven fundamental functions and what will be the use of that. So here you can see here that this is the first function that will be our constant function. Then there is logarithmic function, then linear function, then n log n, then quadratic, then cubic, then exponential. So you can see in the x-axis what I am taking the input, and in the y-axis we are taking that how much time it will take. So you can see in the case of constant functions, when the size is increases, so the behavior is linear. That means for the small values also it is taking the small time. For the large value also it is taking the uh, same time because it is independent of n. For the case of log n, it is taking some extra value. For the linear, it is taking some extra value. But when we are coming to the cubic or the exponential function, so you can see the behavior of exponential function. For the small value of input, it is taking the a small time. But when we are increasing the input size 2 or 10 to the power 3, so the time required will increasing drastically or it is increasing exponentially. So this will lead to this. What will be the basic significance of this graph? That if the problem size will be very small and if we are designing such type of algorithm that is taking the exponential time, so for the small value of a small value of the a small input size, we can able to solve in finite amount of time. But if the size will be increased, so that problem we cannot able to solve in the finite amount of time. So this is the basic significance of this. So if any time, if next time, if I will take some, if the time will permit, then again we will discuss about all these things.